got it right. Okay.
So now, my name is Faiz, and today we will be having a short brief discussion for quadratic equations. So these are the points which we will be discussing today: etymology of quadratic equations, introduction, general form, roots of a quadratic equation, and we will handle some solved examples using the factorization method and using the formula method, the Sridharacharya formula method. So etymology means from where this word comes. This is a Latin word for square, the quadrata is the Latin word. So in this chapter we are dealing with the degree of 2. The variable will be in power of 2, x square or y square or a square. So we are dealing with square. So that's why it is known as quadratic equations. So introduction. A quadratic polynomial is a polynomial of a degree 2. As I told you, for example, any expression. It can be x square plus 2x. This is a algebraic expression with the power of 2. And if okay. So this is an algebraic expression of power 2. If we equate it to 0, it will become a quadratic equation because we have equated it to 0. And we have to find out what are the values of x. In the next slide we will find. So if f of x is a quadratic polynomial, then f of x is equal to 0 is called a quadratic equation. As I told you, if we have a polynomial and if we equate it to 0, this expression will be known as quadratic equation. Okay. So the general form of quadratic equation is ax square plus bx plus c equals 0. What does it represent? The x square, the coefficient of x square is a, which is a constant. The coefficient of x is b, and this is totally constant. There is no variable value here. So a, b and c, these three are real numbers, and a is not equal to 0. Yes, here. A, B, C are real numbers. They can be integer, they can be negative, positive, decimal, and a cannot be 0. Why? Because if we make a 0, this overall expression will vanish and it will no longer be a quadratic equation. It will be like simply a linear equation with power of 1. So this is the general form. For example, x square minus 5x plus 4 equals 0. We can see the a is not 0, it is a power 2. So this is also a quadratic equation. Similarly here, the coefficient of x square is 4 and the power raised to 2, minus 25 equals 0. So this is another example of quadratic equation. Okay, roots. Now to solve the quadratic equations, the answer, the value which we are getting, which we put in the x and the resultant will be 0, those values are called the roots. So if f of x equals 0 is a quadratic equation, then the zeros of the polynomial f of x are called the roots of the quadratic equation f of x equals 0. So fun fact, every quadratic equation can have at most 2 real roots. So this point we have to consider that the quadratic equations, we will have 2 answers, 2 roots that will satisfy the whole equation. Okay. So what are the starting steps for solving a quadratic equation? I have made some 2 points. Just think and try to figure out 2 numbers such that in ax square plus bx plus c, the coefficient of b, we have to think of 2 numbers. Those 2 numbers, by addition, we have to get the coefficient of x, that is b. And with the same 2 numbers, we have to find if their product is thus equal of a and c.
So we need two numbers multiplied together equal A multiplied by C.
Yes.
And added together equal B.
B, correct. Yeah, this I have like a memorization, like a bubble. For example, ax square plus 8x plus 15 equals 0. So we can see the coefficient of x, that is b, is 8. So 8. And 1 into 15 is 15. So 15. So by 15. So by addition, we should get 8. By multiplication, we should get 15. So by hit and trial, like we can find the factors of 15. Factors of 15 are 1 into 15. Factors are 3 into 5. That's it. We don't have more. So 15 and 1, if we add, it will be 16. 5 and 3, it will be 8. So this is what we need. This will fulfill our equation. So 5 plus 3 will be 8. 5 and 3 will be 15. So these are the numbers which we are looking for. So in the next slide, we will discuss how we will use these two numbers to find the roots of the quadratic equation. Okay, this is the same example from the last one. X square plus 8x plus 15 equals 0. This is the solution. So as I circle here 5 and 3, so we will be splitting the b, that is the coefficient of x. We will split 8 into 5x and 3x with a plus sign because it is plus, so plus plus 5x plus 3x 8x. And then what we will do, we will take common from the first two and the last two. We will take common as I have elaborated here, x common, x plus 5 plus 3x plus 5, and then we can see that this part and this part is same, is common. So what we are going to do, we are going to take out x plus 5, and what will be the remaining x plus 3. So this x plus 3 will be in another bracket and x plus 5. Nothing will be here, that is it is multiplying itself. We are not adding or subtracting these two expressions, we are multiplying. We will equate it to 0. Now, after we are getting two factors, we will equate them. We will equate them to 0. So one by one we will equate them to 0. First we will equate x plus 5 to 0. So plus 5 will go there with the negative sign, sign will change, so x will be minus 5. And x plus 3 equals 0, x will be minus 2. Plus 3 will go there, minus 2. So these are the roots. As I told you, the answer of the quadratic equation are known as roots. So we have two roots, minus 5 and minus 3, as I told you before, that in the fun fact that we will have two roots for any quadratic equation. Second one is a little bit complicated example, but the process of solving is same. Here we have a coefficient also of a of x square. So as we can see, same we will do here. 4 into 3 minus 3, that is minus 12. Okay, this we have to obtain by the multiplication, and coefficient of x is minus 4. We have to obtain minus 4 with the help of addition. So since I have already solved it earlier, we need two numbers. When multiplied, give us minus 12, that is a into c, and when added, minus 4. So we will get to conclusion. Again, as I told you, factorization we will do for minus 12. 12 can be obtained by 1 into 12, 2 into 6, 3 into 4. So by this method we are getting 4. So similarly, so minus 4 will be split into minus 6 and plus 2, and the same method we will take common into two brackets and we will equate them to 0 one by one. 2x plus 3 equals 0. 3 will go here with a positive sign and 2 will become in the denominator, and similarly minus 1 will go here, 2 will come in the denominator, minus 1 by 2. So these are the two roots of the quadratic equation. And lastly, we have one formula by mathematician Sridharacharya's formula. He gave us a formula in which if we put the coefficients of x square and x, that is a, b and we can directly find the roots, the two roots, instead of factorization. So this is the general form of quadratic equation, ax square plus bx plus c. These are the coefficients which we will use here, minus b plus minus whole square root b square minus 4ac upon 2a. This is in multiplication, these are in multiplication, this is square. We will take square and take summation and square root. So I have one short example for this one. This I did myself. This is just an image. So the concept is same, it's blurry. So the same quadratic equation I took from the last example to check whether we are getting the same values or not. So the same concept, a is plus 4, b is minus 4 and c is minus 3. And then we are putting the value in the Tharacharya's formula and we will keep on simplifying until finally we will get 4 plus minus, we will get finally here 4 plus minus 8 whole upon 8. So why this is plus minus? Because we did a square root, and whenever we do a square root, it will give the same number but with two signs, positive and negative. So we will take both cases, case 1 4 plus 8 by 8 and second case 4 minus 8 by 8. So we will get 12 upon 8 and we will factorize 3 by 2. This is the first root, and minus 4 by 8 we will get minus 1 by 2. This is the root 2, x2 we can say, x1. So we can see these are the same values which we got in the previous examples. 3 by 2 minus 1 by 2, 3 by 2 minus 1 by 2. That's it. That's the presentation for today. Thanks.
Thank you very much, Mr. Rahman. It was quick and crisp.
Thanks, ma'am.